Hello, my name is Devin Veninger, and welcome to my demo of the game I've been making over the past month called Blink. So, in this demo, I'm going to be going over a few of the game features, a little bit of the code overview at a very high level, just to kind of look at how I implemented things, and then eventually get into some lessons learned and some future work that I've planned for this game. Anyway, to start off with, why don't we go ahead and jump in and play a level or so of this game. See the title screen, nice scrolling background, and little guy just jumped there. I don't control that. The random number generator dictates whether or not he runs across the screen or jumps or any of that kind of stuff. See, he came back quickly this time and jumped at a different spot. Anyway, let's go ahead and hop in and play the first level of the game. So here we have this little thing right here that dictates the start point. And you can put this in the editor mode, which we'll get into later. Anyway, we have text that's actually anchored onto the screen here that's sort of a tutorial, and you can either use the arrow keys to move or the WASD keys, depending on what you like. WASD is very helpful for the editor mode, but we'll get into that later, like I said. So anyway, left for left, right for right, up for jump, obviously. Down only really factors in when we turn on no clip, but that's not an actual game feature. Come to the second part of the tutorial, which is all about wall jumps. Now, wall jumps allow you to jump while in the air on a wall to get higher than you normally would be able to. Now, wall jumps and jumping in general is vector-based, so the initial force applied dictates how high you're going to jump. So if you jump quickly on the wall, you'll have more of an initial force and go higher than you would if you were at the top, which is trying to add on to negative force pulling you back down to the ground. Anyway, to continue, spikes hurt, and spikes are damaging tiles that have insta-death. This little post here is it's a dissolving tile that is a stand-in for a different tile that might be used eventually. But essentially, when you touch this tile, it's going to save a checkpoint, and when you die, you won't respawn at the beginning of the level. You respawn here at this checkpoint. And I'll go ahead and take a look at that in a minute. When I eventually die, we'll try to play this level. Now, the jumping mechanics and the speed at which the character runs aren't based on any sort of real physics. I just kind of toyed around with the numbers until they just kind of felt right when I was playing the game. And there's the death animation. What happens when you die? And you can see in the upper left-hand corner part of the HUD there that my lives went down from 3 to 2. So you have 3 lives to complete the level. There are ways to get other lives, although I haven't implemented them yet in any of the levels I've created. So when that happens, you have to restart the level where you initially entered the game. Whether it's level 1, level 2, wherever you started that session, that's where you'll go to when you lose all of your lives. And as I said, I'm not very good at this game, but I'm going to go ahead and skip apart this section right here with no clip, God mode. Here's where a fun part where we get into the key mechanic of the game and where it gets its name from is actually blink. And so to that we're going to use a space bar and move in the direction in which we want to blink. So you can see there's a little triangle, and actually this little triangle is essentially just an OpenGL triangle that is made with 2 different color gradients. So fairly simple to implement, but looks nice, so I left it in instead of putting out some other growing sort of texture. We can see upper left-hand corner blinks for charging and stun charging, so I'm going to go ahead and blink across. There's a little backflip animation. Fun something. So you can actually blink into walls, which I'll show here. Let's go up to a place where we can do that. And blinking into a wall, like Nightcrawler from the X-Men, results in death. So you can actually see when you're stuck in there, your health drains rapidly, and then you die. So from here, we're going to continue and move on to the second level, where we can explain more of the blink mechanic and see some enemies move. And I'm just going to use no-clip right now to skip through most levels so we can get to level 2. And here we see the level complete. It's green as opposed to red. And so here we are at the start point for level 2. And here we have a little bug that instantly kills you when you touch it. And just in case you didn't believe me. So, well, this is kind of hard to jump across. I'm not, depending on how you want to get across it, there are a few ways. Try to avoid the bug. Or you can do a blink jump, which is another mechanic. After you do a blink, you have an extra jump added to the pool. So to show that, you can charge up and jump across without anything else interfering with it, and able to make a longer jump to get over longer obstacles. You can also blink directly through walls, which could be a game mechanic that I haven't really implemented in any sort of way yet. I've only made a few levels. I've been spending a lot more time on the engine, etc. As you can see, this level is still under construction. Here's where I put in something where there's no way to make it across this section of the level without jumping, so it forces the player to do so. And that's all I have for this level. So anyway, those are the 2 levels that I've made so far, or 1.5 levels that I've made so far. Anyway, let's hop back into the editor mode, and to start off with, I'm going to bring up the configuration options that we have. When the game starts up, you can either click play, or you can click this little wrench to configure the game. And I've set 1080 by 1920, which is the size of my screen, and I've set it to full screen. And I've also told it the level name in which you want to start. So I'm going to name a level I actually have created yet. What that's going to do is when we start the game, it's going to create a new level, empty, that we can then paint with. Alright, and currently I can't go directly back to the home screen. I'm working on it, but that's not in there yet. Now I'm going to start the game and actually play the demo level. Or not. Instead, we're going to go back to level 2 and kind of implement that game a little more. That level a little bit more. So, first what I'm going to do is get past this guy. And jump over here to the end of the level. Using a few cheats. Now, there are a couple key bindings. All of them are listed on the website on GitHub, which is included in the description of this video. But we can pop the editor, and then bring up a little debugger over here to the side. It shows you which tile the mouse is in and the player is in, so that you can actually go through and the mouse is window based, so where you want to find out where a tile is based on where the window is. The player is relative to the global position, so we can put tiles there, and that's where it finds it. Anyway, so what we have here is edit mode, where left clicks add blocks and right clicks remove them. So we can go to remove the blocks here and add some more very easily. And I can use the WASD keys to move around, which makes editing a little easier. And I don't have to click for each one, I can paint them on by just dragging the mouse across. I can also use the number keys to select different types of tiles. And I can use the J and K keys to alternate their orientations. But anyway. And there's also a cool feature, which is live editing, which I'll show for you now. I can turn off no clip. And the player will actually react to the level as if it was actually playing. So I can remove a bunch of blocks from underneath him, and he will fall. I can also kill him if I so desire, and bring him back to the start there. So, when you exit a level, it automatically saves the level that you were editing beforehand. So when we hop directly back into this and go back down there, you'll see it's still all messed up from where we were editing it earlier. I can actually go through and clean this up a little bit. And that's roughly back to where it was at the beginning. So on to a quick code overview. As you can see the directory structure over here to the left side of the screen, I've broken up the package into three main areas, which is my configuration files, library files, and objects. Objects are actually instantiated. Libraries are used to support the code, and the configuration files are hold configurations, obviously. And then out here, outside of all that, is actually the blink.rb file, and then some supporting files to help you install all the necessary components. Notably, in the objects file are the engine and the player. So I'm going to go ahead and remove all of their files here. And what the engine does is essentially implement the Gosu library, which is what I chose to implement my game in. And the Gosu library just has a class that it's derived directly from the Gosu window class, which brings up the window that you see when you start the game, and then turns it into a full screen when we actually initiate the level. And what it gives me is it gives me two main functions, which are update and draw. And these two functions, draw obviously is called every time the screen needs to be drawn. So it's 1/60th of a second, every 60 times a second, so you run at 60 FPS. And update is called continually. So update is continually called, and then draw needs to be called, and then draw is called, and then update continues to run, etc. And so in this, we can actually call the update functions and draw functions for the rest of the code. The player also has the update and draw functions. And when we update the player, we pass in various keys if they're pressed or not. And some things that I've learned throughout this, considering this is the largest coding project I've done on my own without any sort of starting code base to work with, is the number one thing that I've learned is there's far too much exposure in my current code. If I had the time, I'd rewrite the engine entirely before this was due, but I didn't have time. And currently, how the player and the engine are set up is they're very, very intertwined. And also, the player and the engine are very dependent on magic numbers, which is not particularly a good thing to have. Sometimes it's fairly straightforward, like the friction in the x direction is 0.9 unless you are on the floor, and in which it's less. So, but there are a bunch of numbers, and there's a lot of pixel pushing going on around here, and other numbers that could be explained more, and numbers that are actually fairly arbitrary and there for reasons that I'm not entirely sure why they are there. Why I need 14 pixels to the left of my X location, I unfortunately don't know, and that would require a bit more digging than I have right now, than I have time right now. So the basic takeaway from what I've learned is one, cut down on magic numbers, and two, make sure to close off a lot more of the code. I've set a lot of this to private functions, and so a lot of this stuff the player does is all private and cannot be accessed from the outside. And it seems like, lose life, key presses, draw, save, and update are the ones there. But also I need to make the player aware of the level and the window and all the images and sounds and music it's going to be playing, whereas a lot of that should be taken care of by the engine. And then the engine has some things the player needs to take care of instead of, and back and forth. And so they're too intertwined and they're not discrete enough to my liking or sanity. It's not as extensible as I would like it to be. If you wanted to add 2 players, it would be quite a chore to go and make the code work for that. And also, I need to cut down on how many instance variables I have. I've got a ton throughout here and everywhere else. And so instead of in my functions passing in arguments and when I can trace back through other functions, I just have very, very stateful players, which is fine for some things. Like the state, am I dead, is fine to have, but other ones that kind of add complexity to the code without adding many features, and I would like to go back and refactor that and make sure that the player is a lot less stateful, along with the engine and pretty much any other instantiated object in the game. And to wrap up, I implemented this using the Gosu framework, and the Gosu framework is fairly bare bones. The entire philosophy behind the framework when the developer created it was to provide a minimal GUI library for a basic sort of video game without adding many extra tools to it. So it's just very bare bones. It gives you 2 main functions. It gives you update and draw, and then a window class to draw from. And then inside of that, it has basic images, sound, and OpenGL circles and polygons. So very, very bare bones, and lets you implement everything else on top of it completely freeform, which was a little bit of a daunting task for me to be able to come into a project without much support elsewhere, in trying to come up with all these classes by myself and collision detection and all this other kind of stuff that a lot of other libraries have previously implemented. But those libraries added a little bit too much overhead for my liking, for not enough benefit. No one library kind of encapsulated what I wanted. I would have to install 5 or 6, and that would have removed the cross-platform availability of the game right now. And so another thing I did was I implemented the game in Ruby, which is my most comfortable language going into this course, and even more so leaving it. However, if I could redo the game, I don't think that I would use vanilla Ruby again. While it runs fine on my desktop has 2 670s and SLI, NVIDIA 670s and SLI, so it can handle this game fairly well. And I've also got an i7 in there, so this computer can handle it no problem. However, on my laptop, there's some frame rate delays and things like that that kind of really slow it down, and that basically stems from Ruby being an interpreted language. And when you're calling a draw function 60 times a second, that's a lot of calculations that have to take place on a low-power processor if you're not using, like I said, this computer has an i7 inside of it. So what I would do to fix that is I would either start out using JRuby, which is Ruby that runs on the JVM, which is a pretty big speed boost. Rubinius, which kind of takes care of some multi-threading and gives you some more options to kind of distribute how Ruby runs and where it runs, so that I could optimize it a bit more, even though it requires a bit more tinkering than other options. Or move to a completely compiled language such as C++. The Gosu library itself also has C++ support, so if I wanted to stay familiar with myself, I could use the C++ library for Gosu. Also, there are like the XNA framework for C# and other sorts of libraries out there to build games with. But I do thoroughly enjoy the Ruby implementation for prototyping. I have here a game that works, and that has done a lot of proof of concept. Even if it can't run quickly on lower power computers, while I'd have to rewrite it to put it into a different language, It definitely is a very, very quick and easy prototyping platform that makes it easy to just to hop into a game, start digging around, and build one up, and kind of really learn what's going on underneath the hood, underneath the collision detection algorithms and pathing that you might find, because you have to implement it all yourself. There's no A-star. You have to write the algorithm in if you want it. Anyway, a few other things that I would like to add in later would be in the edit mode. It currently, you just have to put the block down, but I'd like it to kind of show a preview of the block where it would go if you clicked to put it down. You know, that's where the block would go, kind of like a preview with like a light block, maybe a little bit less opacity or something like that to make it look like you're editing it. And eventually also have enemies in edit mode. Currently edit mode only supports tiles, and so you can only edit the tiles in the room. Enemies have to be added manually through the configuration files. If we go in here and look at level 2, we can see here that I put that enemy directly right there on the 20th tile in the X direction and the 9th tile in the Y direction, and another one that falls off the screen instantly, just to see what would happen. But as far as the levels are, I like YAML, being able to describe a level in this. YAML's a markup language, similar to JSON or other ones, just the syntax is a little bit different. And then the cool thing about it is Ruby can directly import YAML. If we see here, it's just that is all I need to build a data structure called config that loads all this information into it. So we can see enemies. I have an array of hashes for the enemies and all the tiles in a level, width, height, background, all this other kind of stuff that I can put in and edit. And I can also take any data structure and compress it down into YAML to kind of pickle it for later, so I can read it back out from a file at a later date and have the state saved, which makes saving the game very easy. I can just save off the player and reboot him. And finally, I'd like to eventually implement moving platforms, because currently tiles are static and there's no support for them to move, and the player can only respond to moving objects in a fatal way currently. If enemies are moved and they touch, then the player dies. So I'd have to write another section of code that handled the player interacting in a non-lethal way to moving objects. Anyway, this is a quick demo of Blink, and I've had a good time this month implementing this game. So that's about all I had to show you, and hopefully you liked the final product.